Welcome to this explainer. Today, we're diving straight into a story that completely changed how human beings interact with the physical world. You know, we really take for granted that when we open our eyes, we just see what's in front of us, right? But for thousands of years, the actual mechanics of human vision were an absolute mystery. We're going to look at how an incredibly brilliant 11th century scholar fundamentally revolutionized our understanding of light. And get this, he essentially invented the modern scientific method along the way. Let's see how he pulled it off.
Section 1. The ancient mystery of sight, and how exactly we see. To truly appreciate this breakthrough, we've got to set the stage with ancient science.
Okay, let's start with a seriously bizarre historical puzzle. Do your eyes shoot light? I know, it sounds exactly like a comic book superpower. But believe it or not, ancient Greek philosophers like Empirical, around 450 BCE, genuinely believed that the goddess Aphrodite literally lit a fire inside our eyes. They thought vision worked because our eyes were essentially shooting out light. Even brilliant mathematicians, guys like Euclid and later Ptolemy, backed this up. They thought you were constantly projecting invisible laser-like radiation to perceive the color and shape of things. Just think about that for a second. They honestly thought you were projecting invisible beams into the night sky just to see the stars.
So, this brings us to an incredible historical standoff. On one side, you have the extra emission theory, which is this idea that eyes emit light. On the other side, the intromission theory, which argue the exact opposite, that light from objects enters our eyes. Now, early followers of Aristotle had a rough, kind of vague idea of intromission, but the debate just raged on for centuries without any hard proof. It was this massive theoretical tug-of-war that actually took until around the year 1000 CE to finally be unlocked by someone who demanded way more than just philosophical guesswork.
Section 2. The First Scientist and Alhazen's Revolution. Enter our protagonist, the man who dared to look at centuries of revered Greek philosophy and simply say, "Prove it."
Meet Abu Ali al-Hasan ibn al-Haytham. In the West, he's widely known as Alhazen. Born in Basra, Iraq, right around 965 CE, this guy was a true polymath. He made huge contributions to astronomy, math, medicine, the whole shebang. But he's most famous as the revolutionary thinker who was the earliest to figure out that a scientific hypothesis absolutely must be proven by confirmable mathematical experiments. His face even graces the Iraqi 10,000 dinar note today, honoring his massive legacy as the father of modern optics.
Alhazen possessed this beautifully modern, skeptical mindset. He famously stated, "If learning the truth is the scientist's goal, then he must make himself the enemy of all that he reads." He knew that to find the actual truth about light, he couldn't just blindly accept ancient texts. I mean, he argued that if our eyes were shooting out rays to instantly fill all of space the second we open our eyelids to look at the sky, well, that's highly improbable. Plus, he noted a very practical thing. Looking directly at the sun physically hurts our eyes, which literally makes no sense at all if our eyes were the things doing the emitting. He needed to test this in reality.
Section 3. The Darkroom Experiment and Proving Intromission. This was his key. So how exactly did he debunk the ancient I-beam myth once and for all?
Well, he designed a beautifully simple step-by-step setup that would become an absolute cornerstone of the scientific method. First, he stood inside a completely darkened room that had just one tiny hole in the wall. Outside, he hung two glowing lanterns at different heights. When he looked inside that dark room, he observed that the light from each lantern illuminated a distinct, separate spot on the interior wall. And here's the critical part. Each lighted spot formed a perfect, direct straight line with the hole and the specific lantern outside.
Then came the interactive part. He found that by covering a specific lantern outside, its corresponding spot of light inside the room would go completely dark. Uncover it, and boom, the spot reappeared. The crucial takeaway here is that this gave the very first irrefutable experimental evidence that light does not emanate from the human eye. Not at all. Instead, light is emitted by self-luminous objects, like those lanterns, and it travels from those external objects in perfectly straight lines through space.
Section 4. The Book of Optics, or Kitab al-Manazir. Having fundamentally cracked the code of light transmission, Alhazen didn't just stop there.
All of his rigorous methodology was poured into a masterpiece that would change the scientific world forever. He spent years compiling his discoveries. He conducted physiological experiments on the eye itself and tested the refraction of light through transparent mediums like air and water.
He completely mapped out the anatomy of the eye, theorizing how the crystalline humor receives light rays to form a visual cone, which then transmits the image to the brain via the optic nerve. He even tackled the really tricky problem of why our vision isn't just a blur of overlapping rays, using complex mathematics to explain how we process light perpendicularly.
All of this culminated in a massive 7-volume treatise. The scope of this work is just incredible. It goes from Volume 1, covering the basics of light, colors, and vision, right through to visual perception, errors in reflection, and eventually Volume 7, covering complex refraction. Translated into Latin in the late 12th or early 13th century under the title De Aspectibus, these 7 volumes essentially became the absolute foundation of optics, physics, and mathematics in Europe for the next several centuries. A real game-changer.
Section 5. A Legacy in Light and the Birth of the Camera Obscura. The impact of this book literally cannot be overstated. Let's look at the ripple effects.
You see, Alhazen's dark room experiment directly birthed what we call the camera obscura. A camera obscura is a dark room or device with a small hole that projects an inversed and reversed image of the outside world, basically acting as a model for the human eye. Before this, physical optics, which studies what light actually is, and geometrical optics, which studies how light moves, were pretty separate fields. The camera obscura forced these two branches together. By providing a physical device that mimicked the human eye, it showed exactly how light, moving in straight lines through a pinhole, projects an inverted and reversed image of the world outside.
Over time, inventors added lenses and mirrors to these devices, and by the 17th century, the optical camera obscura had sparked absolute wonder across Europe. Just imagine seeing a live, moving, full-color projection of the outside world inside a dark box for the very first time. It was pure magic. Constantine Huygens was completely mesmerized after seeing one in 1622. He declared, "All painting is dead in comparison, for here is life itself. Figure, contour, and movement come together naturally therein."
This intense fascination had a massive impact on the art world, too. In fact, it sparked a heavily debated historical theory that master 17th century painters, most notably Johannes Vermeer, might have actually used the camera obscura to achieve their stunning, atmospheric photographic realism. Now, we don't have direct written evidence or, a 17th century receipt for a camera obscura belonging to Vermeer, but the sheer precision of light, color, and luster in his domestic interiors heavily suggest he was either deeply inspired by or practically utilized the projections of this exact optical device. The evolution of that simple dark room eventually led us directly to modern photography, cinema, and yes, the screens we stare at every single day. So, from photography to 3D glasses and kaleidoscopes, how many optical technologies do you use today that owe their existence to a man in a dark room 1,000 years ago? As you look through lenses and screens today, I want to leave you with this final thought. Think about how an ancient scholar's skeptical quest for truth still fundamentally shapes the way we see the world right now. From polarized 3D movie glasses to the very camera lenses capturing our lives, how much of our modern visual world would even exist without an 11th century scientist who simply wanted to know how we see the stars?